We'll have people coming in, trickling in because there's a big traffic jam out there, and I'm guessing you know that better than I do, probably. So welcome on behalf of the College of Science and the College of Mines and Earth Science. Welcome to the Frontiers of Science lecture series. And as many of you know, this is the longest lecture series in the history of the University of Utah. Last year it celebrated the 50th anniversary, so we're starting the next 50 years right now. My name is Daryl Butt. I'm the Dean of the College of Mines and Earth Sciences, and also representing Dr. Henry White, who's the Dean of the College of Science. And we have the pleasure tonight of listening to a very distinguished alumni from our university. And I'm going to have Dr. Mike Nelson introduce him in a little bit. Before I do, I did want to just say a few words about Frank Brown. Most of you knew Frank. I can tell by the audience. I've seen a lot of your faces here before, and Frank unfortunately passed away a few weeks ago, and rather unexpectedly. He was the dean of our college for 25 years, and was a professor at the university for nearly 50 years, and accomplished incredible things for the university and for our college. I just want you to be aware that his memorial is this Sunday at 6 p.m. and there's an image of Frank that's kind of going by every 15 seconds or so that has some information on a scholarship for Frank. So we're trying to establish what's called the Frank Brown African Scholarship at the Leakey Foundation. So it's not a University of Utah Foundation scholarship, it's a Leakey Foundation. And Frank spent most of his career working with the Leakey Foundation, funded by the Leakey Foundation. In fact, the photo that you see of him with his arm hanging out of a Land Rover is a Land Rover that used to be owned by Leakey himself, and he gave it to Frank. And Frank was not only an incredible transdisciplinary scientist, but he is also a fantastic Land Rover mechanic, as I understand it. So, but Frank will be missed. If you do choose to donate to the Leakey Foundation, you'll have an opportunity to fill out a little box with a comment about Frank, and his daughters will get that comment. So we're trying to raise $1 million for that fellowship, or that scholarship, excuse me, and we have a donor that's matching donations, a very generous donor, obviously, that's matching our donations. So if Frank were here right now, he'd tell me to quit talking about him and move on with the seminar. Before I do, I just want to say, because I'm afraid I might forget at the end, our next Frontiers of Science lecture will be on Thursday, December 7th, and the speaker is Robert Hazen. He's a senior staff scientist at the Carnegie Institute of Geophysical Laboratory, and is the Clarence Robinson Professor of Earth Science at George Mason University. And he's going to be talking about the story of Earth, how life and rocks co-evolved. And so I'm guessing he's going to talk about isotopes a little bit. So what I'd like to do now is turn the mic over to Dr. Mike Nelson, who's going to tell you a few stories about our speaker. And Mike, if you can come up.
Well, thank you, Dean Butt, and welcome everyone to this lecture. I'm delighted to introduce Frank McAllister. Frank has been a great supporter of the College of Mines and Earth Sciences since he moved here to Salt Lake, and I got acquainted with him. I knew much of his biography that you read in your program. I knew that he had worked for ASARCO and for Stillwater Mining, but as I got acquainted from him, he told me he was from Cache Valley, and that's where I am from. And as we talked, found out that when he was a student at South Cache High School, my dad was his band teacher. And I had later known some of his younger siblings. Frank had moved on by that time, but we established that connection, and he's not only a valuable supporter of our college and our programs, but a good friend. Frank has some unique insights, I think, into sustainability. He has wide-ranging interests, as you'll see in your program, in addition to a distinguished career in industry and with many charitable organizations. He's very active in the Boy Scouts. He was key in working with the Boy Scouts of America to establish a merit badge having to do with mining to help Boy Scouts understand the importance of mining and earth resources and proper management of those resources in our world. It's interesting to note that Frank spent 33 years with the ASARCO company. ASARCO stands for American Smelting and Refining Company originally, and the smelter that you see out by the Great Salt Lake that's owned by Rio Tinto now, the original smelter there was built by ASARCO. But the interesting thing about ASARCO is they were started by, was it 7 brothers? So the 7 Guggenheim brothers who were, their father was a Jewish immigrant and they grew up in New York and they got into the mining business and did very well. The interesting story I wanted to share with you is one time I went with my wife to Dawson City in the Yukon, which is where the Yukon Gold Rush took place, and we were looking at the maps of the old gold rush, and there was a section of the town called Googieville. And that was the camp where the workers for the Guggenheim Company lived. So the Guggenheims at one time had interests all over the world, and Frank worked for them until that company was sold, and then he moved on, as you see in your program. But that's enough talk. I'd just like to turn the time over to Frank now for his presentation on sustainability.
I think I'm up there. So, all right. Well, thank you, Dr. Nelson. Thank you, Dean Butt. Appreciate that very much. I'm delighted to be here, delighted that there'd be so many of you that might want to come and talk about sustainability. And we're going to go through this rather rapidly because there's a lot of stuff to cover. And so if I cover something too fast, come up and hit me on the head after and we'll talk about it. But I want to move quickly because I want to make sure we cover it all. First of all, you have to understand that Dean Butt, a couple of days ago, essentially challenged me with the idea of sustainability and said maybe it's resiliency that we have to worry about instead of sustainability. So I wound up with a preamble to this whole thing, trying to rationalize or trying to figure out whether sustainability and resiliency basically coexist or whether they're separate. But essentially this is a problem within the sustainability community that has sort of created a different challenge to it, and that is resiliency the better word? Well, let's talk about the two of them just for a second. Resilience is how to help vulnerable people and organizations and systems persist, even thrive in unforeseeable situations. And sustainability aims to put the world back into balance. So I then found another article that was entitled Sustainability versus Reliance, and in the end of that, you'll see under the red circle there that essentially it says, well, it concludes, in short, resilience thinking is a complement to sustainability, not a substitute. So they probably work together. I'm not going to argue that with anybody until I study it further, Dean Butt, but we'll see what happens. So when you really come right down to it, perhaps the two of them do coexist. But what we're talking about tonight is sustainability. And conceptually, when you talk about sustainability, you have to think about what it's all about. And essentially, it's something that can last, will continue, won't run out, can and will change if and as needed. And I essentially put that as in the category of perhaps resiliency. But let's look at the word can last. And what is it that we as human beings want to last? And it's pretty simple and pretty straightforward. Human existence, life, families, children, friends, goes into where we live, the towns and the states and the countries and the economies that we have, the businesses and the churches and the schools that we populate, and obviously the environment, nature, and obviously resources that are provided from nature. Well, you have to still understand that it's people-focused in the end of the day. And so if we go back to the United Nations 30 years ago and look at what they described as sustainable development, they basically say it's development that meets the needs of the present generation without compromising the ability of future generations to meet their own needs. Well, that sort of says we better understand what development means. And development essentially is growth, expansion, activity, change. That again would imply a little bit of resiliency in the process of that. But in the end of the day, if we put it personally, what we're talking about is sustainability might simply be defined as meeting our needs without diminishing the ability of our grandchildren, so forth, to meet their own needs. Well, let's look at sustainability as you would search it on the internet. This is what sustainability, there's the three pillars, and the three pillars are social, environmental, and economic. And if you look at each one of those and then go down through it, essentially at the end of it, it says the word indefinitely, indefinitely, and indefinitely, so that we want to be able to have social and environmental and economic activities continue indefinitely. And that's what sustainability is sort of supposed to be. Well, that's fine when we scrutinize what sustainability may look like. The problem is that doesn't tell us how we get there. And so essentially, securing sustainability, or the how, is what we're going to talk about tonight. So it's a little bit different than the three pillars. We're going to talk about how we get to those three pillars. And I haven't found anything like this anyplace, and I think it probably is as important that we as a public understand that. We as people of the world understand how we get there. So I've identified 6 fundamentals, or foundations, if you will, of how we do that, the how I call it. And essentially, you're going to say, well, why these 6? Well, I'm not going to tell you right now why these 6, but we'll go down through each one of them during the evening here to try and help you understand what it is. First, starting with people and people needs. So first, you have to understand that nature can take care of itself without people. I think we all understand that. It did before we got here, and it would after if we're not here anymore. But so we're trying to talk about how many people are we talking about, and what do the people need or want or require, and what must people do in the process of that. So we're going to work through that and try to see, well, how many people are we talking about? And currently, somebody was telling me in June, and I'm not sure they made the count themselves, but they said we passed the 7.5 billion mark here in 2017 in June. Well, that's just one mark, but if now we're talking about where are we going, well, by 2050, the projections are that we'll be at 9 billion, and by 2100, we'll be at 11 billion. The problem with that is that's a probabilistic projection. And probabilistic projections are just that. There is a risk as to whether it'll be higher or lower. And you talk to those who are in math here and you'll understand that. But what we're talking about is, will we be back down to 7.5 billion by 2100, or will we be at 16 billion plus? So essentially, it is a process that we're going through to understand just exactly where we're going to be, but it's important to understand where we've come from as well and how we got to where we are. Now you'll see on this slide, I've sort of slammed 2 of them together, one about the industrial revolutions, which are being talked about as being 4 industrial revolutions at this point in time, and also the growth of the population over this period of time. Back when we were in muscle tone, that was when the farmers had to use horses and their own muscles to be able to plant and grow and harvest and then carry that food. The largest towns, the epic towns we know of now, of New York and Paris and London, were about 8 square miles. That was all because they couldn't essentially have enough muscle tone to get the food into any place bigger than that. And by the way, getting it into that city was a pretty big task because they had to bring it from out in the county, out in the country. So essentially what's happened, we moved from that in the first industrial revolution, which began 1780, something like that, and we then wound up with steam engines and being able to essentially allow people to do things other than just use their muscles and their horses to be able to grow food. So at that point in time, the population begins to creep up. Then we get into electricity. 1870, 1860, 1870, 1880, when got the grid out there, and all of a sudden the population has got a spurt to it because now people can do different things than they had done before. And so by the time we get to the 3rd industrial revolution, which is computers and automation and things like that, all of a sudden we're on an uphill road that just simply doesn't look like it's going to stop. And you'll see that red bar there. That red bar is the rate at which population is growing. And then the blue is obviously what the population is happening. We'll come back to the red bar in just a minute. Well, went back the wrong way. So a couple of turning points there, 3 turning points. You can see the ones in the first industrial revolution, the one in the second, and then at the third, all of a sudden, the line begins to come down. And we'll talk about that further in a minute as well. So the reality is that period is my lifetime. 1942 to today, the population went up 3.3 times. Nobody else in the future is going to see that because the population is going to peak out and perhaps even come down in the future. It just depends on a number of things that we're going to talk about here yet tonight. Well, let's examine that a little bit, because this is sort of the world population growth rates, and you'll see how it's coming down. We're back there in 1970, we were at about 2% thereabouts, and now we're at 1% in 2017. And then we're going to go down to 0.5%. Well, look at what happened. So back in 1970, we had 3.8 billion people on the earth. If you grow at 2%, that's 75 million people a year. So you move forward to 2017, we now have 7.5 billion people on the earth, but we're only growing at 1%. Well, that's still 75 million people each year. So as we move forward, that population growth rate is falling further. It goes down to 0.5%. And by the time we get out to 2050, at 9 billion people, obviously, now we're talking about 45 million people, billion people. So it's still a big number. So let's go to the most populous countries and understand what's happening there. It's very important to understand. So the column on the left shows sort of where we are today with the China is the top population country. If I were to round it up today, it wouldn't be what it is right there, but it'd be about 1.5 billion over in China. You got India right on its heels and coming up quickly. The United States is in third place, has been there for a long time now. And then you've got behind that, you've got Indonesia. Well, look at the other column, 2050, and see what happens. All of a sudden the rankings are changing, but it's more important to look at 2100 because the rankings have changed dramatically, absolutely dramatically, and here's how they go. So on the right-hand side of that column there, that's what the rankings are in 2100. On the left-hand side is where they were today. So you see the India and China, Nigeria. My goodness, Nigeria is at 752 million people. They've come up from 7th to 3rd. But more importantly, look at the Congo and look at Tanzania. Look at Ethiopia, look at Niger. The percentage increase in those countries is just dramatic as to what's happening. So they've come up in the ranks to the top 10, and at this point in time, essentially what we're saying was, how's that happening? Why is that happening? Well, it's the fertility rates, the number of children per woman in those countries is what's happening, and that's what's driving this. So you see those first 10 nations, their average birth rate is 6.4 children, babies, per woman in those 10 countries. Over in the lowest rate, it's 1.3. The US rate is 1.9, but between the 1.3 and the 6.4 is a 5 times multiple. But look at this, because all of those nations, all 10 of those nations with the highest population or highest birth rate are in Africa. And so let's look at a bit at Africa because that's where the countries are. Now, that's 10 of the 55 nations in Africa. So let's go a little bit further. They're currently a little over 1.3 billion because that number is 2016. But by the time they get to 2050, they're going to be at 2.6 billion. And by the time we get to 2100, they're going to be at 4.4 billion. That's 4.4 billion out of the projected 11 billion. Now, mind you, all these numbers, again, probabilistic projections. Are they real? Not on your life. They're not. You have to remember that. And please don't go home and say, we're going to have 11 billion. We're projected to have 11 billion, but use that as sort of a caveat to the whole thing. But look at this, Nigeria. Do you know how big Nigeria is? Anybody have an idea about how big Nigeria is? Take Texas and Oklahoma and a little bit of Louisiana. That's Nigeria. Can you imagine that? 752 million people in Nigeria in 2100. And look at those numbers right up in the upper right-hand corner. That's up from 187 million people by 300%. And look at the numbers right next, down to that. That's in the European Union. The 48 countries in 2100 are projected to have 645 million. That's 100 million less than Nigeria. Dramatic, epic growth. But look at this. They're currently at 17% of world population. By 2100, they're 40% of world population. Okay, now, I'm not trying to frighten anybody. That's just the projections. That's where they are. That's where their growth rate is going. So let's look at this a little bit differently. So this is the growth rates by continent. So you see Asia up there. It's kind of peaking up there at the top and then coming back down a little bit. You know, and Africa's zooming up there, and you have to say if we could project that another 10 years with the two things cross. I don't know the answer to that. These are probabilistic projections again. But look at the rest of the world. All the other countries are either flat to down or modestly up. So the issue here is that Africa will have a lot to say in the future, and we need to just understand that. So let's look at what we use. These are the population projection factors. So I've underlined Africa in each one of these as we go down through them, but the first one is the total fertility per woman. Now you'll see that circle around there doesn't say 6, like we showed earlier with those 10 nations, because this is all 55 nations of Africa. So when you add them all together and take an average, it's now 4.43. And dropping is the projection. Okay, let's look at under 5 mortality. And this is good news, because it's dropping as well. So that means that there's going to be more population because the kids are not dying, the babies are not dying, they're living beyond 5. And they're coming down to where you would expect the world might be if you look way over to the right-hand side there, because they'll be down to 14. Now, that's not where the world is, but it's a lot closer than where they were in 1990 at 167. That's just crazy. Okay, then let's look at life expectancy. My goodness, dramatic change there. So they're going to live longer. So again, that's a factor into the population equation. But we see all of these factors. So for you, again, you math students, these are the factors that you have to put into the probabilistic projections to be able to understand where we are. Let's go back to that chart. But this throws up a question about migration. What's going to happen if you got 4.4 billion, and can we feed them? And the answer is we don't know yet. But we're going to have to do a lot of changes to be able to make sure that 4.4 billion people can be fed on the continent of Africa, or we're going to wind up with a migration issue. So I looked at it, and I'm not going to take you all down through this thing, but quite frankly, in the past, what they've done is done probabilistic projections with respect to population. And then they've done deterministic projections with respect to migration. Well, that means that somebody's going, I think it's going to be that. And then they put that in with the population probabilistic. Well, that's sort of skews the whole thing. It isn't the right way to do it. So what they've now done is done a probabilistic projection with respect to migration as well as population. They put them together, and the result is that there's great uncertainty about the populations of Europe and the United States, and the rest of the world is fairly consistent with where they would have thought it was going to go. So let's look at the United States just for a second. So here is the migration. These are immigrants. This is not population. This is the population of immigrants. And the projections, again, remember these are probabilistic projections. So they're not real numbers when it comes right down to it. They're real forecasts. And so it's looking like the Asian immigrant population is going to grow rather sharply over the next several years. This goes up to 2065. The Hispanic population of immigrants in the United States is going to go down, and you see the rest of them there. Well, when you put that into the population projections for the United States and do it on a percentage basis, you'll see that essentially what's happening there is, yes, the Asian population is now 14% when you get out to 2065, Hispanic 24%, the blacks are 13%, and the whites are 46%. So a big change. So there's going to be some changes in the demographics of the United States, even further than what we know now. Is that good? Is that bad? It is a fact. It's going to change, and we're going to have to embrace it and work with it. And that's just exactly what we're doing now, and it's what we can do in the future. Okay, now, what do 7.5 billion people do? That's a lot of people. So let's sort of see what this analysis says. So 1.9 billion people are under the age of being able to work. So they're children, babies. Okay, then we've got 577 that are older than able to work. How's that for, is that politically correct, John?
Not quite.
Okay. Then we've got 430 that are unemployed. 430 million. And you put that together, you got 2.9 billion out of 7.5 billion that sort of depend upon the rest of the population. That's 60% of the rest of us to be able to help make sure that they're going to be okay. So let's look at them. 1.7 billion in services. Goodness sakes, I thought they would all be in manufacturing. But that's not the case. You got 1.4 billion who work in agriculture. And you say, well, that's too many. Well, think China, think India. They say, oh, okay. So that's where those agricultural workers are, because the United States, I got to tell you, you go to Montana, you go out to Iowa, they're all in town now. They don't work, they aren't out on the farms anymore. There's very few people out on the farms because of automation. We'll talk about that in a bit. 800 million people are in industrial jobs. Now, half as many as in the service sector. And then you got 400 million that are entrepreneurs. And obviously this could be from the guy that's running a barbershop downtown in Tanzania or wherever it might be. So that's the case. So we put that all together and say, okay, but what do the 7.5 billion people need or want? And I've gone back to 1943 and said, I don't know what they want, except they all want more. Because if you look at Maslow's, and this again is a theory, this is not a law, this is a theory of psychology, but essentially you start at the physiological and you go to the safety needs and the love and belonging, and once you've achieved those, then you go to the esteem, and then you go to self-actualization. At least that's what my professors explained to me. But what it is, it's more. All right, so let's dissect that. So they want an improved standard of living and a quality of life. And as will 9 billion people, and as will 11 billion people. And just consider the multiplier effect of that. And all I'm doing here is showing you the growth rate in the population, which to 2050 is 20% and to 2100 is 47%. I haven't applied the multiplier effect of what we all are achieving, and that is a better life and a better quality of life. And we all get it. I mean, look at the seismic shift in China. That's extraordinary what happened in China. In fact, I'll tell you a story. 1988, my wife and I went to Hong Kong to see a plant that we had just acquired. Then I went over into Shenzhen, which was a town right next door that had 500,000 people. We owned 45% of the business, government owned 55%. That was the rule for doing business in China. So the government person that represented the 55% met me at the train station. We took off, went to the plant. Now, it was a kind of a humble little plant, but nevertheless, all we were doing is making chemistry to plate bicycles with. So then after we did that, we came back to a tall building, the tallest building in town, 10 stories, made out of concrete, all the way up to the top. We went up the top for lunch. So the government officials, through the waiter says, what would you like, the dog or the cat? I says, what else do you have? He says, we got snake soup. I says, I'll take the snake soup. So we went ahead with dinner. Then he comes up. Now, all of this is through an interpreter at the time. Today he would speak English, but at the time it was through an interpreter. He says, we must go to free enterprise in China or our people will starve to death. And it was almost a head jerk to me. I says, wow, this guy gets it, or the government gets it. Wow, that's really neat. Then we talked about the business for the rest of the lunch until at the end, just about time we were going to stand up and leave. He says, you know, we got a problem here in China, especially in Shenzhen. He says the people in the manufacturing plants won't make what the government tells them to make. They make what they can sell in the black market on the street. And I didn't know what to say. I didn't say anything because I said, wow, you don't get it, do you? Because you got two completely different statements here he's making. I go back to Hong Kong where Marcia's waiting for me, and I tell her, I said, one of two things is going to happen here in China. Either they're going to go to free enterprise very rapidly, or there's going to be a government put down. You all know what happened in 1989. That was Tiananmen Square, June of 1989. So the government was just simply saying, you're going to do it on our schedule, not on your schedule. And that's basically what happened. By the way, that was also the year that the Berlin Wall came down. So communism had a bad year in 1989. However, look at this. This is just blows your mind. Okay, from 1929, now granted that's the bottom of the recession, to 2010, we've had a 427% inflation-adjusted growth in GDP and the standard of living in the United States. That's 5.3% per year. That's extraordinary. Extraordinary. So fundamentally, what we're talking about is going forward, we're going to have to expect that those 9 billion people and those 11 billion people are also going to want to have a better standard of living. And I went back and said, okay, from 1999 to 2013, what's the world GDP growth rate? The real growth rate was 3.7%. That's sort of right there in the middle of the page. And the current world GDP per person is about $10,750. And now you take 2% growth instead of the 3.7% growth. I'm assuming that China factored into that 3.7 really big, and their growth rate is down now. So I'm saying, let's just take 2% world growth or 3% world growth. But what that means is that at 2%, that equates to 93% more, but when you put the population on top of it and do the multiplier effect, you get 131% more at 2% growth. 3% growth is 218%. So you understand what our challenge is. That's the challenge for all of us, not just for China, not just for the rest of the world. It's us as well. We're part of it. This is going to surprise some of you, really surprise some of you. This is those living in extreme poverty in 1981 was over 40%. Over 40%. Now you had to factor China in because that was before China had come a long ways. But look where it is now, under 10%, down dramatically, in addition to many more people. So we had 4.5 billion people back then when they were at 40%. Now we got 7.5 billion people. Dramatic improvement in the world. So it can happen. Sustainability can happen. That's what we have to be able to believe in. So just in short, sustainability means meeting the needs of many more people with an ever-increasing standard of living while preserving the ability of our environment to provide for those growing needs. That's the next point. The next fundamental is natural resources. You know, if you look at it, I mean, this is a cartoon, and I've doctored it up a little bit to make sure we've got everything on there. And obviously, you got lots of categories on there, but what I've done is then broken them down into my categories. These are the three categories that I believe we have natural resources in. The ones captured, that's the wind and the sun and the rain and maybe water out of a river. The second one is the nurtured natural resources. That's the plants and the animals. And the last one are the extracted. And that's everything there is. And it's the minerals, the metals, water, petroleum, and all those things that we rely upon. And look around you. That's all there is. There's nothing artificial. My mom used to tell me, oh, that's artificial. You better not eat that. I says, don't think there's anything artificial. And the problem is that we don't recognize it, but every person born in America is going to need about 3.125 million pounds of metals, minerals, and fuels in their lifetime, and that leaves out the food they're going to eat, that leaves out the captured natural resources. So let's look at just two of those. Let's look at phosphate, let's look at copper. I'm going to stay with copper for the moment. I bet you every one of you got something like this in your pocket, right? Who doesn't have a phone in their pocket? Oh my gosh, oh wow, okay, all right, I'm wrong. Well, those of you who do have a bonanza, because in addition to copper, there's 46 elements in that phone, in your pocket. 37 of them are mined metals or metalloids. Now, it's hard to figure out what's going in them because the companies don't want to tell you what they're putting in them. That's sort of secret. So you have to look at what's coming out of them. And the answer is, there's down at the bottom there 35,000 pounds of copper and 772 pounds of silver. That's pounds, not ounces. 75 pounds of gold, again, not ounces. And 33 pounds of palladium. That's what comes out of 1 million smartphones as they're recycled. So, and I put up there in the corner for those of you who are curious, just those 4 metals out of 1 million phones is worth over $2 million. But let's stick with copper just for a second, the recycled side of it. So recycling of copper. So here are sort of the factors. How much copper is recycled annually? Well, about 9 million tons. And why is recycling preferred? Well, it's cheaper for one, but it saves on energy, CO2 emissions, and waste. The next question, any difference between mined and recycled copper? And the answer is absolutely none. No difference in purity, no difference in quality. In fact, when it gets down to the bottom, what is the recycled content of copper? It's about 35% around the world, globally. So, on average, 35% of the copper in that phone you got in your pocket is recycled. Or maybe 40 or maybe 30, depending upon where you got your phone and what copper they had that day. But that's the case. Now, let's go back to that cartoon again and look at the natural resources. It's important to understand that some of them are renewable and some of them are non-renewable. And let's focus on them just for the second, because that's the one that we have to worry about in terms of sustainability. And so what do we have to do? We have to reduce, we have to reuse, we have to recycle. And in addition to that, we have to understand just what life is all about. There it is. That's what it's all about. That's what makes life fun for us. Now, not everybody's got all those things, but nevertheless, everybody is impacted by all those things. Now, let's look at phosphate just for a second. This comes from, the picture of these two rocks comes from Soda Springs, Idaho, from Monsanto up there. And essentially, phosphate, the main use is for the production of phosphate fertilizers for agriculture. But Monsanto up there in Soda Springs, they use it to produce phosphoric acid, which is used in soda and Roundup. And yeah, that's what it is, soda and Roundup. So when you drink your Dr. Pepper tonight, well, you know you're drinking rock right out of the ground in Soda Springs, Idaho. But when it gets down to phosphate and fertilizer, on the left-hand side is a crop treated with phosphate, on the right-hand side, not treated. Dramatic difference. That's what mined product coming out of the ground helps the farmers do. Now, despite that, or yet that, mining is sort of this in-your-face thing. Not much we can do about that, but mitigation, rehabilitation, and reuse are terribly important factors in mining. You know, the mitigation is done during the mining period. Obviously, rehabilitation is done after, and then if it's done sufficiently enough, that project or property can be reused. The big Jamboree site of the Boy Scouts in West Virginia was the site of many coal mines, and today it is a very, very nice place where they hold the Jamborees. It's been great to be there. But put in perspective, we have to understand that only 1/4% of all the land in the United States has been used for mining. And every state has mining in it. Doesn't matter where you are, it's mining. Now, you know, it might be coal mining, it may be stone mining, it may be copper mining, it may be whatever else it is, but there is mining in every state in the Union. But not to diminish this footprint, because you have to understand that a quarter or 0.25% is 9,500 square miles. That's the size of Maryland. And if you look at it on a world basis, if in fact the numbers would be the same there, that's 287,500 square miles, or the size of Zambia. But it's still much less land than is used for agriculture, for urban development, for forestry, or for national parks and wilderness areas. I still get this pang in me, though, when somebody comes up and says, I don't like mining, I think we ought to do away with it. In fact, we took some surveys on some universities back east, and the comments said, well, that's an old industry, let's get rid of it. Well, pull that phone out of your pocket and stamp it back into the ground then, because that's where it came from. Now, you have to worry about my manners, so I don't do it that way. We talk to them nicely, but nevertheless, that is the sort of the urge But they just have to know that is all there is to sustain us. And it's nothing new, because Georgius Agricola in De Re Metallica back in 1556, he actually died in 1555, but the book was printed posthumously. And what he said, now he had written a number of chapters and defending this and that, and he comes to this sort of summary. And what he says is, but what need of more words? If we remove metals from the service of man, all methods of protecting and sustaining life, our health and more carefully preserving the course of life are done away with. And he goes on to try and make that case further. He says, if there were no metals, men would pass a wretched and horrible existence in the midst of wild beasts. They would return to the acorns and fruits and berries of the forest. They would feed upon herbs and roots, which they plucked up with their nails. They would dig out caves in which to lie down at night, and by day they would rove in the woods and plains like beasts. And summarizing, and inasmuch as this condition is utterly unworthy of humanity, with its splendid and glorious endowment, will anyone be so foolish or obstinate as not to allow that metals are necessary for food and clothing, and that they tend to preserve life? 1556. Now, if he were around today, he would add to that and say, will anyone be so foolish or obstinate as not to allow that sustainability dictates while using what is needed, we must also protect our environment, reduce, reuse, recycle, and innovate. And that is the number 3 fundamental or foundation. And it's, why innovation? Why do I harp on that? That's just going to happen. No, it's not just going to happen. You have to actually drive that as a society. Natural resources are finite and will grow more costly or become fully depleted over time. Innovation can vastly reduce our individual dependence on and use of natural resources. And the last one I love, it makes life better. And quite frankly, that again comes back to resilience. So it's happening. This is what I watched when I was a kid. My grandkids say, you can't watch a radio. I said, I still know what that radio looks like even today, even though that was 65 years ago. I remember watching that thing, and I remember the B-Bar-B Ranch, and goodness, what were the other ones on there? Mike, do you remember some of them? Forgive me. So this is what we got today. But this is what we watch. Right? How many times do you pull it out of your pocket or purse today? 80 times on average. 80 times. Holy cow. Even I did it. Wow. Well, innovation. This is what my granddad had. I remember it on the wall, hanging in his house down in St. George. That's what my dad had. And look where we've gone. Look where we've gone. Well, let's stay with cell phones for a moment. All right? So, what are our cell phones? You know what they're used for. You do it all the time. I don't have to tell you what they are. Sending messages, making calls, calculator, maps, whatever it might be. And those guys didn't know that was taken. There they were, right in the midst of it. That's my grandkids. How about that? They do that every Sunday. Right? Right? Yeah. Okay. Now, in 1983, when the first mobile phone, now it's a stretch to call this a mobile phone because you had to have a wheelbarrow to carry it around in. But it cost $4,000 each. Today, that would cost $9,783 in today's dollars. Can you imagine how many of us are going to carry one of those around, let alone pay for it? Okay, so today, the phones cost somewhere between $400 and $1,000 because there's 250,000 patents that went into that thing. Mind-blowing. That's the work of a lot of you people right here in the future. Innovation's terribly important. 250, and look at this. I'm blown away by this. It costs you $250 a year to recharge your phone every night. Wow. Sustainability, you bet. You bet. And look at the penetration. Oh my gosh, 492 billion mobile users, that's 66% penetration. And we're not even factoring out the children that don't have them or the people that, well, I guess everybody can afford them. Well, sorry. Look, innovation is all around us. I just searched on the internet, on Google, and said, what were the you know, the most important innovations of the 21st century, you'll note that most all of them are electronics when it comes right down to it. And there's going to be more. They're on the drawing board right now and moving out. And the important thing is to note is that they're all empowered by mining. How about that? You like that, Daryl? Okay. So that's where we were. So let's look at mining innovation, because we've come a long way. That thing just blows me away. That's my wife standing right there. And I had her stand there because I wanted to sort of show you that when somebody's 4'6" standing by this truck, no, 5'6", sorry. I'm in trouble now. but look at that thing. Now, this is down in the Kennecott mine at the time. It's no longer the Kennecott mine, but it was the Kennecott mine at the time in Ray, Arizona. That's the biggest shovel and the biggest truck. The biggest shovel had a 15-yard dipper and could load that truck, because it had 20 tons in the dipper, probably 4 swings and a bit, because it was an 85-ton truck. And the cost of those two pieces, now you don't buy one shovel for one truck, but nevertheless, a shovel and a truck at that time was $1 million. Today, in today's dollars, that'd be $8 million. But look at what's out at Kennecott today. It's extraordinary. That truck can carry 320 tons, and that's if, in fact, it doesn't put a light bed on it. They can put a light bed on it, and that's going to increase the tonnage it would be able to carry. That shovel, 120 tons a swing. It can more than fill that truck up in 3 swings. Now, that's sort of equipment technology that's happened there, and it's cost, yeah, a little bit tough. So it's $41 million for that truck and the shovel, as opposed to $8 million for the smaller ones back in 50 years ago. And the innovation in mining is going to continue. It has to continue. And I show in the red here, autonomous mine site infrastructure. We've got trucks in the mines today being driven by computers autonomously. We've got alternative energy coming at the mine sites. We've got 3D mapping. I tell you, it's extraordinary what they can do with 3D mapping. Going down underground, you drill the holes down the ground, say here's where it is, and you can actually plan your mine with 3D mapping. And then you got the automated tunnel borers. They're extraordinary. We have one up at Stillwater Mine going back in the mountain 5 miles. It's just extraordinary what's happening there. Let me tell you this story, though. This is the Stillwater Mining Company. I was there for almost 13 years, and the reality is that there's an opportunity in mining for going beyond essentially what's required and making that really innovation when it comes right down to it. So when I got there, 2001, former chairman had said, well, we've created a good neighbor agreement. It's a legally binding agreement. So I looked at it and said, it says we won't allow mine or processed waters to escape in the river flowing alongside and overtop the mine. We would grade and reseed the tailings and waste piles on the sides and tailor them as much so that they would look like the natural surrounding. Those were a couple of there were a couple more that were even worse. But as we reviewed the agreement in the community, I found that some of the management were still scratching their heads as to why we entered into this agreement. And I guess I have to say I had my fingers up scratching my head as well. But some neighborhood agreement leaders also remained prickly and doubtful about the fact as to whether or not we would honor this. But I concluded we will honor it, despite sort of some other naysayers about it. But we will honor this agreement. So the two gratifying and quite surprising results in the end. If I had more time, I would tell you about a story in Amarillo, Texas, but at a copper refinery. But essentially, what happened, some in the management, at the time, the leadership was sort of these prickly environmental people who were trying to protect up everything, but they also had some good old ranchers on the committee. And when they saw that we were serious about it, over a few years, they sort of elbowed out those people and became the leaders of this thing, and they were very comfortable with us and what we were doing because we were honoring the agreement, and it worked out really well. We became very close. We invited them to our board meetings, for heaven's sakes. You don't really do that unless you know that it's going to work out okay. Second thing that happened is even more surprising. When we would go to the DEQ or the EPA, DEQ in Montana or the EPA of the federal government, and we would put in a proposal for a permit, they would say, have you run this by your good neighbor agreement people? We say yes, and they said, okay, we'll get it on the way. Just something you wouldn't really understand that it could believe, but that's essentially what happened. Now, second thing we did was, here's the smelter. Now, I took this picture off the internet knowing that I would get the picture that I wanted. So this is Google Earth. I just screenshot, there it is. Do you see any smoke coming out of that stack on the left? No, and you could take that picture any time of the day or any time of the year and you still wouldn't see any smoke coming out because what we put in was a plant to make gypsum out of the SO2 so we scrub the SO2 out, make gypsum, give it to the farmers. Farmers put it on their land to emolliate the soil that they have. So essentially what we wound up doing, we have a permit to emit 74 tons of SO2 a year. We emit 2.2 tons a year. When it comes down to comparing ourselves against our peers, that's 0.004 pounds per ounce of production, where the others are in the, oh goodness, they're probably 7.5 to 33 pounds per ounce of SO2 emissions. So we wind up being a good neighbor, not just having a good neighbor agreement, but we become a good neighbor. And I'd submit to you, any of you that are the students of mining, you need to take that into consideration as you go out and do your career. All right, let's move to agriculture. Wow, extraordinary what's happening. And if you're not in ag, you don't even think about innovation in agriculture. That's, they just go out and they just plow and harvest. Well, the results are dramatic because here's the world, population since 1961 up 240%. But look at the yields on the wheats, the rice and everything, they're up by 400%. The United States, okay, we're population up 175%, the cereal is up over 300%. And look at the land. The land's flat. We're not using more land. Population, this is in China, they came from a lower base because they didn't have all that innovation over there and all the other things. So they're up. Their cereal population or production rate index is up almost 550%. Their population's only up 200% because they were reaching that peak where they're slowing, but their land under cultivation, flat. India, a little bit different because their population is zooming up. They were starting from a higher base, so essentially their cereal production index is still above the population, but nevertheless not quite as strong as China. But when you look at Nigeria, population there is up 385%, and their cereal production index up about 320%, so they got some work to do. But obviously that population is going to continue straight up like that. So again, we come back to the question about sustainability of Nigeria. And obviously, they don't have much land because you got Texas and Oklahoma and a little bit of Louisiana there, and that's about it. Look at this one. This one, I love this one. 1942. We were producing under a ton of corn per acre. Today it's 4.9 tons. That's a 5-ton increase, five times increase over that period of time. Extraordinary, 42 to today. And if you look at that blue line, that blue is saying that's how much land we have under cultivation in the world. It stayed flat 1961 through today. And the green represents what we would have had to have if, in fact, we hadn't had the increase in production in these fields. Or if you look at it a different way, if we needed to produce as much today as we produced back in 1961, we would use only about 68% of the land mass that we used back then. Rather dramatic. Now, the top 3 farming innovations of the last century include the 3-point hitch. You're going to say, what's that all about? The 3-point hitch. Semi-dwarf strains of wheat and the Green Revolution, and genetically modified GMO crops. All right, let's look at that 3-point hitch. It's pretty pedestrian when it comes right down to it, but there was a fellow, Harry Ferguson, an Irish farmer, developed back in the 1930s. Ford Motor Company took it on, mass-produced it. It's used all over the world today, and I dare say you probably can't find a tractor out there without a 3-point hitch on it, and it revolutionized what the farmer can do with a tractor. Rather than pulling a plow behind a horse like it was before with the tractor, now they can actually push that plow down into the ground, and they can empower the tractor to go faster. Okay, let's look at this. Now I'm going to have to use some of my notes to get down through this, because we got 4 guys here who really sort of, this is kind of this thing where it's a small world. You have to say, why do we want wheat shorter? How many of you have been and seen a wheat field after a rainstorm and a windstorm? So what happens to it? Laying flat. What's going to happen to that wheat? It's going to stay flat and rot, and they're going to plow it under. So essentially what they're doing is shortening the things, and what happens is it doesn't use as much energy in growing that staff, and more of the energy goes in growing the kernels. So you have higher production. I'm not going to go through all these guys. One of them is Italian. One of them is a USDA who was over in Japan, and he got some samples there, sent them back to the United States. He sent them to Vogel. Vogel reproduced them and made some better wheats out of them. He gave them to Borlaug. Borlaug was down in Mexico, and he was provided and given a, goodness sakes, what he was given. He was given the Nobel Peace Prize in 1970 for his role in the Green Revolution and the fact that we had a triple production rate in the wheats as a result of what they did over that probably 70-year period of time, because Stampelli was back in about 1900 to about 1920, and then the others came after that. But most, you'd say, obviously the fell of the salmon, it was over after World War II. That would have been in 46, 47, 48 in that period. So great things happened there. Okay, now GMOs. Yeah, perspectives differ sharply on GMOs, but from a scientific and productive standpoint, the technology is sound, is being used under strict government regulation, and its foods have been safely consumed for dozens of years by most of us without incident. And how it works, the genes of a variety that has some desired traits like drought tolerance or yield potential or herbicide resistance. You take those genes that are introduced to the genes of other varieties that might have some good things, enabling the farmers to grow crops with traits that are difficult or impossible to achieve by conventional breeding, which took place on the former slide. So GMO crops can't alone solve our food crisis as we move forward to more population, but it is one of the answers. And I like the big bird one here. This one I love. So here you go. You got birds in 1957, 56 days years old, and 2 pounds. You move to 1978, they're 3.9 pounds. You move to 2005, and they're 9.3 pounds. Wow. And what you have to understand is that poultry will become the animal production or protein of the future. That's just, it's almost that way today, but it's going to be that way because when you raise beef, wow, it just doesn't, it's not a sustainable thing. So eat it and enjoy it right now. All right. Okay. Thank goodness there are multiple areas for innovation in ag. I'm not going to go down through them all. George Bernard Shaw said there's no love sincerer than the love for food. I'd add to that, there is no need greater than the need for food. So let's go to what they're doing now. We've got, these are the top 15 ag technologies that are coming out, being launched right now. Let's look at only 12. By the way, those that are in red there, the numbers that are in red are all electronic based. The electronic industry is going in and helping the ag guys. Look at this one though. See the swarm of birds down there in the left-hand corner? You go up to the right-hand corner, those are drones. And what they're trying to do is teach drones to be able to flock like birds or swarm like birds, so that in fact what they can do is monitor, predict, cultivate, and extract crops with no human intervention. Scary. Or good. Anyway, look what's happening to the cost of food over this century. Dramatically down with the growth in population. And then when you talk about the food cost as a percent of family disposable income, it too is down. The blue line going up through there is the population growth, and the black line coming down through there. Although it's kind of jagged, it's coming down. So can we continue that? I don't know the answer to it, but by golly, that's what innovation can help us do. Now, the 11 innovations that have changed history, all of you know this list. You've seen it, and obviously it has some things on there that are a little bit old and we don't even think about it anymore, except the electric light. But the steam engine, we don't talk about that much anymore. Of course, antibiotics is fine. The telegraph, that's gone by the way of innovation. But you have to understand that innovation isn't just about brainstorming new ideas. It's about how businesses stay running. These are big businesses in my lifetime that either have hit a rough spot or in fact are completely out of business. Kodak was an important one because we sold a lot of silver to Kodak over the years because that's how they made their film. They don't do much of that anymore. That's innovation. Should have Kodak been on the forefront of that? I don't know, but they should have figured out that this was not going to be a good trip with electronics taking on the photography and us carrying around a camera, every one in our pocket, and taking pictures and sending them home. It's changed a lot. And, you know, I put, and while they're still in business, Sears on there. Sears had the model for Amazon. They were the catalog company of the world, and they would ship things out by postal. I mean, we lived out on a farm, and you wouldn't go to town to shop at Sears. You'd get on and put a letter in and send it off, and your stuff would come back by mail. That sounds like Amazon, except you do it on a computer today. So they had the model. They missed the boat. Okay, now in my lifetime, just one person's lifetime, these are the things that I look at and say, wow, you know, car dependability and their controls. How many of you seen, has anybody seen a car stopped alongside the road with a flat tire in the last year? You have, okay, sorry, we'll go on. Interstate highways, my goodness, we lived in Ames, Iowa for a while. We had to drive through every burg in town and across the country to get back home here to Utah. Today you don't do that. You can do it in a few hours instead of a few days. Jet planes, refrigerators. We had an ice box. The iceman had to come around every 3 days and put ice in that ice box. And air conditioning, what's that? That's a fan, you know. Okay. Television, computers, the internet, solar panels, mobile phones. But stay tuned, they're coming. Look at this. This is a driverless truck. It doesn't even have a cab on it. This was shown down last year at the Mine Expo in Las Vegas. And no cab on it. And driverless cars are coming. And by the way, I made a count. You know, I went out and counted them all. There were about 20,000 cars out at the Salt Lake Airport all the time. It isn't the same cars, but they're there all the time. Do we need 20,000 cars out there? Maybe we can use that metal in something else. Because what we'll do is we'll pull out our phone and go kerplunk. The car will show up out front here. We'll go get in it. And it'll take us off there. Driverless, by the way. Drop us off and pick somebody else up, go on the way. You won't even need to own a car. Sorry, that's the future. Here's what's happening. Advanced materials, you know, goodness sakes, cloud technology, autonomous vehicles, synthetic biology, virtual and augmented reality, artificial intelligence, and so forth, robots, and on and on. Lots of stuff is happening. And then when we come to global warming and the problem there and trying to greet that or meet that, clean power, smart transport systems, sustainable production and consumption, sustainable land use, and smart cities and homes. Look at smart cities. Holy cow, broad thing. Now, we can start small. And how you start small is you say, let's make that stoplight a go light. Make it a smart light. So you flow down the street and you don't ever stop. Right now, people are running red lights by mad. How many of you people seen somebody run a red light today? Yeah. Okay. Okay. So what happens is, frustrated, you run the light. And then you say, okay, I'm frustrated, I'm going to speed. I'm going to get on the freeway, I'm going to go 90 miles an hour. By the way, do you know why we have 70 miles an hour on the road? That reduces the congestion on the highways. Doesn't take you as long to get there, so you're not on the highway that long. How about that? Okay. So then what happens is you're copied by others, it degrades the law, and that's where we are today. If we have the smart lights, what you're going to do is you're going to reduce the fuel use, you're going to reduce the car repairs, you're going to reduce the drive time, you're going to reduce the environmental emissions into our valley, and you're going to encourage people to obey the law. Okay? That's just my pet peeve. Okay? Let's go on to the next. Peace, getting along, and manners. Terribly important, terribly important. And this is war. 32 events in 150 years, 200 million people killed in those 32 events. Let's talk about the big wars alone. These are, you know, the ones where you got millions of people killed. The Belgian Congo Free State issue. 8 million people killed by Belgium down in the Congo. World War I, 20 million people. Go to World War II, the Holocaust, and Chinese Revolution. So many we don't even know how many it was. 50 to 80 million. What's that? Is that responsible to put out that type of a range? That's all we knew. Wow. Okay, it's not sustainable. Look at what Mao did in China. Holy cow. You add those two numbers together, that comes up to 49 million people just to keep himself in power and keep the communist government in power. Not good. However, Steven Pinker, who's a Harvard professor, says violence has been in a decline over long stretches of time. We may be living in the most peaceful time in our species' existence. I can't argue with him. That's dramatic what's happened. That's 1945 on the left-hand side and going down to today. And yes, that has the Vietnam War and the Iraq War and the Korean War all in there, but the trend is down dramatically. So one reason why, because we have democratic governments. They're much less likely to engage in wars. And more countries are becoming democratic, but okay, you have to put that factor that in. But let's look at the democratic governments. So you have to follow this line down there at the bottom. I got the arrow too, and countries have to move over to that yellow and green because that's where the Democratic Party is. And obviously what you got now is Canada, the United States, and Australia, and the United Kingdom, and countries around there. So let's go 15 years increments. Here's 1950, a little bit of change, 1965. Oh, they're moving to red. Well, red's good because that's moving from blue over to red. And then you got 1980, and then you got, look at Russia in 1995, because 1992, 1993 was when the Communist Party left. And look at what's every time. There's 2015. Now, you got China in red, and we talk about there being a communist party, but quite frankly, it's not a communist way of life over there. It is just simply that they still have a communist party that's running. All right, let's move to the next thing that's sort of my pet peeve. Manners. Goodness sakes. In the relaxed atmosphere of the American society, many of the rules of social behavior that were routine in the generation long ago today are largely ignored, if not even known. And American casualness is often interpreted as rudeness in other societies. And that comes out of the State Department's handbook and the manners for diplomacy, because he says, what does it say if the representatives of the world's most powerful nation are indifferent to the appropriate respect owed to the representatives of other nations? Well, in fact, what happens, they can be taken as a personal or a national insult. So quite frankly, we all ought to have some type of manners. I know we all have manners. The question is, are they good or are they bad? Okay? You know, it was clear back in 1952 that Amy Vanderbilt wrote her best-selling book on manners. Well, we still have manners today and still have the opportunity of doing them, maybe a little bit different, but good manners will open the doors that the best education can't. That's what Clarence Thomas says. Manners cost nothing. You know, I don't like rude people. And then on the left-hand side there, my wife tells me about this all the time, putting your phone away and paying attention to those talking to you. There's an app for that called Respect. Isn't that right? And those words in the center, thank you, I'm sorry, please, excuse me, are the words I have to use when she tells me to put my phone away. But they're easy. There they are. But society has challenged. The social discourse that's going on, not just in our country, but in the world, is a bit of a struggle and a bit something that we have to look at. And do you understand on the right-hand side, just above the black chart there, do you understand the personal challenge this puts to you? So that you, your own social discourse, is going to be one of good manners and peace and civil approach. Very important. All right. So how do we get there? We have to have the right leadership. This is not a political comment. Sorry. This is just simply we have to have leadership. And what is leadership? Well, it's something that creates an inspiring vision. It motivates people to engage in the vision. It builds a team to achieve that vision, and it manages the delivery of the vision. That's sort of what the rule book says what a leader is. And you can go in and get all sorts of descriptions of what a leader is. And of course, around this circle there, you'll see vision and support and encouragement, recognition, stimulating work, and all of those are terribly important. but good leaders are essential to bring peace and bring accord in this world. And leadership, what's expected of a leader? Well, these are some of the things: appreciation, strategy, commitment, responsibility, humility, purpose, determination, principles. You can find these things. You should study them. You should know. You should judge the leaders that you follow by them. Is that a good leader or is that not a good leader? All right? Now, World War II ended following VE Day in Europe on May 8th of 1945. Oh, wait a minute, we had to have VJ Day first before it ended, and that was August 15th of 1945. But the United Nations was established October 24th of that same year. What a year. Wow. But you have to understand that it took the leadership of two individuals, Mr. Roosevelt and Mr. Churchill, came together and invited Mr. Stalin. He wasn't necessarily in there for the instrumental creation of it, but they invited him in because they had to have respect from the world for creating the United Nations. And the vision was to establish a leadership body aimed to help bring peace and accord to the world. The number of nations they had to start with was 51. They now have 193. It's all but 4 nations in it. Those 4 nations have a particular reason for not being there. So another reason that we have greater peace is because of the United Nations. Now I have to say I've been one that has been critical of the United Nations and some of the things they've done over the years. But nevertheless, it requires nations that are there to talk with each other. And that's important to be able to bring accord. Now reflect upon the leadership of these guys. Leopold II of Belgium, Joseph Stalin of the USSR, Hitler, Tojo, Mao, Saddam. What are they known for? Which dictator killed the most people? What did they lack? And what they lacked is terribly important. And that's called integrity, honesty, truthfulness. They just lacked it. That was it. Otherwise, Mao wouldn't have killed 49 million people. So the last point is integrity. The last principle, the last fundamental or foundation of what we need. What is integrity? Well, in short, honesty, truthfulness, honor, veracity, reliability. Somebody said I was in the Scouts. Yes, honest. I am trustworthy, loyal, helpful, friendly, courteous, kind, obedient, cheerful, thrifty, brave. They're points of integrity. On my honor. You know, do a good turn, be prepared. Fundamentals of a person of integrity. But the most important test is doing the right thing even when nobody's watching. Okay? Now, there are 3 reasons, 3 selfish reasons to have integrity. The first one is you don't have to doubt yourself when you do something because you know you did what was right. The second one was everybody, you gain the trust of other people. They like you because they know they can trust you. And the last one is because you become a role model. And a role model typically becomes a leader because everybody wants to be able to trust their leader. Crazy. Now, absent leadership with integrity, we risk world wars, atrocities, oppressive regimes, civil war, cartels, gangs, thugs, some of which we already have today, but a lot of which we don't have, and loss of loved ones in the process. And yes, they have leaders, but those leaders lack integrity. Now, wisdom, knowing the right path, but integrity is actually taking it, and it's more. Because integrity sort of is in everything. Everything. What if you pulled this thing out of your pocket and you didn't know whether you could make a call with it? Because it may not be on, or the system may not be there. Or it may tell you the wrong time, or the text you're getting is from somebody you don't even know. I mean, that already happens, I understand. But nevertheless, the integrity of our system and our structure of living. See that bridge up there? People drive across it, run across it, ride the box across it. The green building behind it was a building I worked in for many years. I would dare going up in the building in the elevators because I knew they had integrity to get me up there. And I knew that bridge was okay when I'd walk across it at lunch. It wasn't going to fall down. And the food you buy, look down in the lower right-hand corner. What if you went into the store and you couldn't trust the food that you're buying? Or if you drive down the road and, the driver in that other car, or the car doesn't have integrity of the roads or the signs. I mean, integrity is everything. You understand where I'm going? What about that data breach? Holy cow. What about being able to trust the data you have on your computer? It makes life go. It's very important. So it isn't just you having integrity, it's the whole system and structure to have integrity. That's what you engineers are all about, making it happen that way. You have to have integrity to do that, because you have to believe in what you're doing. All right, this is a culture we're talking about. Starting in the upper left-hand corner, people determine culture. People do. That's what we have. 7.5 billion people have. They determine culture. And you move that center circle there, and the culture determines our use of natural resources, whether we're going to reduce, reuse, and recycle, whether we're going to build here or build there. Okay? And then you move over to a culture of innovation. We have to have a culture of innovation, and it starts with you. And then civility. Holy cow. Wouldn't it be nice if we could have peace and human accord and manners, because they are a measure of culture. Culture starts with leadership, just the fact. But integrity is the foundation of a sustainable culture. So, we've just started. Lots of challenges ahead. Lots and lots of challenges. You know, and they're going to keep coming. This was in the news just a couple of days ago. Pollution linked to 9 million deaths in 2015. Holy cow. Could be, at least, down in the corner it says. That was what the article said. This is what it looked like in 1968 when my wife and I moved to Los Angeles and I worked in the city of industry in a recycling plant. There was a rule for driving. If it was like this, your plate was odd, you could drive on an odd day, but you couldn't drive on an even day. If it was an even day and you had an even license plate, you could drive. That was the rule. That was the rule. If one thinks about it, we really knocked pollution on the head. The rules and regulations of the 60s and 70s essentially made our water safe to drink and air responsible clean. And that's what 2005 Los Angeles looks like. And this, believe it or not, is the consumption of gasoline. I couldn't find the number of cars in 1968, the number of cars in 2017. But this is the consumption of gasoline in Los Angeles. Nearly tripled. Nearly tripled. So you know we got a lot more cars because they're getting better mileage today than they did back then, because that's helped reduce the smog. But catalytic converters was the other key to reducing that. Well, the challenges are going to keep coming. Let's just look at that fuel, because I've got some friends over at the University of Colorado in Boulder who I'm working with on some satellite business, and they say we need to leave it all in the ground. Don't take any of those carbons out of the ground. Leave them all in the ground, will be just fine. I says, well, okay, how are we going to eat? How are we going to get from here to there? He says, well, I ride my bike to school. I says, I understand you ride your bike, but that isn't going to work for the world. So here's what's happening, 1% increase per year going forward in the use of energies. Now, are nuclear and biomass and solar and hydro going up? Yeah, they're going up faster than the others, but coal remains flat, doesn't go down, it remains flat. And obviously what we've got is both gasoline and oil going, well, gasoline's just about flat, but oil, yeah, oil is going up. 1966, when I left the university in 1966, went back to New York, this is what it looked like. That was the worst smog day in New York. Now this is what it looks like. Everybody looking real close? You have to have a boat to get to work. Well, essentially what that is somebody's characterization of what might happen with global warming. You know, I don't know where global warming is going to go. I'm not taking a side one way or another, but here's some points of view. They go both sides. You've seen them, you've heard them, but it's a fact that temperatures are up by 1.4 degrees over the 20th century. But this too can be resolved, because like air pollution, a solution lies within human accord, leadership, integrity, innovation, people-driven initiatives. Yep, they're going to continue, but they need leaders of integrity to be there. And just remember what it will take, and that obviously the majority of those are people-driven. The natural resources are what makes it right. And why do I tell our youth about all this? Because they're the leaders. They're going to have integrity and so forth. you know all the points I've already talked about. Are we ready for tomorrow? Believe it or not, we are sustainable. We are resilient, and our job is securing that sustainability. This is what it takes. That's how it will be achieved, and that's how it is realized. Got to give credit to our World in Data, started back in 2011 by Max Roser of the University of Oxford. It's extraordinary. Go in and see it. You'll like it. He got some funding in 2016, and he's added 5 or 6 people to his group, but otherwise it's just him putting his own dollars up and asking for donations. But it's a great, great site. So, Darrell, I'm finished. I think I've used up all the time.
Frank says he thinks he's used all the time. We might have time for a few questions if anyone has any questions or comments. Yes. Let me bring you the microphone.
This needs to be disseminated widely. Have you thought of writing a book?
John is my next door neighbor, and he and I have been talking about me writing this book for 4 years.
Well, quite a while.
Yeah. And the answer to that is yes, I have, and the answer to that is it should be written, and I would hope that I'll be able to do it. With you prodding me, we'll get done. Thanks, John.
So thank you for the talk. Would have been interested in seeing some data on metal extraction of some kind and how that's changed over time. The problem is, of course, when you take something out of the ground, it isn't there anymore.
Correct.
So that operation is not sustainable.
Yep.
The problem we're up against right now is that we're going after marginal lands where, for example, in Bristol Bay in Alaska, they want to put in a mine that would have a serious impact on the salmon fisheries there and on the natives there. And so they're going after land that's precious in order to keep up the rate at which we need. So do you have any information about what extraction is?
You know, I don't, but I agree with you totally. And that's part of what I was attempting to pull together, but I haven't got it together. And I think Mike would probably know it even better than I do. But it is a reality, is what you're saying. And essentially what we're doing is we're going to wind up going down deeper. We're going to send robots down there instead of miners because it gets hot after you get past 3 miles. And you can't send air conditioning down there because it doesn't work. You're putting air conditioning down, blowing out hot air and blowing out cool air. Well, it just is fighting against each other. So at 3 miles down in South Africa, they have to put ice down there to keep it cool. But we will create a cool room down there, put the workers down there, they'll assemble the equipment and send them out as robots. And they will mine, and that will happen. And it's happening already. We have it at Stillwater a bit. Obviously, the guy's off about 20 feet away from the piece of equipment, sending it in where it's unsafe. But nevertheless, it's robotic type equipment. And that will happen from the surface rather than down underground. But you're quite right, and that needs to be put together. And if I get the book written that John's talking about, it'll be in there. Has to be.
One or two more questions?
Just a comment on the extra, immediate and direct cost of sustainable practices.
Yep.
The numbers you threw out with Stillwater were really impressive. Can you comment on how that mine was financially competitive with similar businesses while having a 10th or 100th?
Great question. Love the question, because where I started on sustainability was knowing when I joined the company, the price was $1,094 for the price of palladium. And it had gone just like this. I says, whew, that's not going to stay up there. And my board says, Frank, you don't understand. You just got here, you don't understand palladium. I says, I understand bubbles in the market. By the end of the year, it was back down to $800. The next year was $350, and the next year was $180. Now, in the meantime, I had signed a contract with Ford Motor Company. Thank goodness for Ford Motor Company, because the floor price in the contract was $500. That contract had 10 years to run. It was an extraordinary contract. I'd never seen anything like that ever again. But I knew that by 2010, when that contract would run out, I had to have that price of palladium back up. And it stayed there at about 25% of the price of platinum, clear until 2010, when I wrote the article called The Case for Palladium. The price of palladium went up 100% that year, went up to 48% of the price of palladium, or platinum, and today it's 120% of the price of platinum. And what we did was we simply went out and marketed palladium. That's why my hair is palladium blonde. So we marketed palladium to create sustainability for my workforce and my company. And that was what it was all about. So, yeah, did it cost us a lot of money to do that marketing? Yes. But was it money well spent? I think so. Some people would argue with me. They say, well, the market did that. And I said, well, of course the market did it. An informed market. I informed the market. We made palladium jewelry. We had, what's the lady's name? Who was it? Pamela Anderson. She was so over her heavy metal, platinum, you know, well, it was her boyfriend. So over her heavy metal, she'd gone to palladium. We had her down in Las Vegas, standing up on the stage saying that, and that was sort of what we did. So, right. Now, what did these other things cost us? Nothing. Because we were able to get the government's consent to work with us with respect to permits, sending that tunnel boring machine back 7 miles or 6 miles back into the mountain, the permit just came forward just like that. So it costs you nothing to do what's right. That's my belief. And taking the SO2 out of the air, yeah, that plant was expensive, but we're able to sell the what do we call it? What is that stuff? Gypsum. I've been away from it too long. We're able to sell that gypsum to the farmers at a reasonable price so that they can sustain their farms as well. So it was sort of a communal thing when it comes right down to it. It's really good. Really great. By the way, Stillwater is now owned by a company over in Africa. So instead of me buying a company in Africa, we got bought by a company in Africa. Darn. Okay. Did I answer your question? Okay.
One more question, anyone? Over in the back right. Oh, thank you.
Yeah, I just had a question. I mean, you made a pretty good point of kind of like the growing population in the world and how everybody wants to have a higher standard of living and the resources required for that.
Right.
But I mean, to a certain degree in the extractive industry, there's like deposits or a certain nature are like anomalies. And I mean, we've heard of peak oil and how, you know, oil isn't really being made anymore. Well, maybe in a couple 100 million years. But I mean, I just read an article about peak gold and probably peak copper. There's, you know, increased exploration costs with decreased kind of reserves, ounces in the ground being created. Yeah. So do you think the mining industry will trend more towards like economies of scale? Or are we going to have bigger mines at these legacy sites? Or are we going to trend back towards like a mom and pop sort of more mines mining higher grade deposits?
The higher grade deposits are gone. We're now mining the low grade deposits. That takes bigger equipment, takes a higher price. And that's really what's happening. So the price goes up to commensurate with the need for the product that's being produced. Just when I started, the price of copper was probably, you know, I'm going to be wrong, whatever I say, but 40 cents a pound. Today it's $3.40 a pound or $3.15 a pound. Why is it higher? Well, inflation is one, but number two is the grade of the ore that's being mined today is much lower than we could afford to mine back in 50 years ago. So it will change. Now, I made the comment about pulling your phone out, tapping on it, and having a car without a driver in it, pull up in front, you get in it, takes you to the airport and drops you off and picks somebody else up. That car is not going to be a big car. It's going to be a self-driving car, but that takes 20,000 cars out of service out there, could take 20,000 cars out of service out there. But I'm just talking about Salt Lake Airport. What about Denver and Chicago and New York and so on? And, you know, we've got lots and lots of product that's been brought to the surface and is there to be used for other purposes if, in fact, innovation takes us there. And it will. I promise you it will. They're driving driverless taxis down in Phoenix today. And other places, I'm sure. That's some other company down there. That's not the big guy.
So I am in high school, so how can I have like integrity and how can I help like innovation? How can I help my high school with innovation or integrity?
Well, for one thing, you have to have a curious mind with respect to innovation. You know, my thought up here about having smart stoplights is kind of a dumb idea, except it's really a smart idea because I'd really love it. And I know there's a lot of other people about there. Is there ability to do that? You bet there is. We all carry a smartphone around in our pocket. Why can't there be some way to create better traffic signals? That would be innovation. And I'm sure there's somebody has it out there so that traffic can go 40 miles an hour down the road, because if you do that, you're going to hit every light green. Now, yeah, they do have that in some places, but not enough. So that's one of the things. But when it comes to integrity, you know people of integrity. You know them right now. They're the role models for you, and you should be the role models for others. You understand what I'm saying there? That's how integrity is spread. And it's terribly important for our whole society. We're not going that way. We should be. We need more role models.
All right, I think we've used a little more than our allotted time, but we
Sorry
appreciate
about
your
that, everybody.
questions. And thanks again to Frank McAllister.
Thank you for an outstanding presentation.
Oh, well,
As you
thank
leave,
you.
just a
Thank
reminder
you.
that the
I'm gonna
next
turn this
Frontiers
off.
of Science lecture will be on December 7th,
Is there any
as
way
Dean Butt mentioned, with Robert Hazen,
They've
talking
actually
about how
filmed it.
rocks and life co-evolved.